This is the EdExcel GCSE 9-1 Maths Paper 2 from the June 2018 series, and this is from the higher tier. Question number 1. For part A we have to simplify m cubed multiplied by m to the 4. Well, when we have the same base and we are multiplying, we would add the powers. And so if we add the powers, we will end up with m to the 3 plus 4, which simplifies to m to the 7. We have m to the 7. For part B of the question, we have to simplify 5np cubed all to the 3. What this is the same as is 5np cubed multiplied by 5np cubed multiplied by 5np cubed. And so 5 times 5 times 5 is 125. N times n times n, that's n cubed. P cubed times p cubed times p cubed, well, that is p cubed raised to the power of 3. And so we end up with 125 n cubed, and then we've got p cubed to the 3. When we have a base to a power to another power, we multiply, so we end up with 125 n cubed, and then we have p to the power of 3 times 3, which is 9. So we have 125 n cubed p to the power of 9. And now for part C, we have to simplify 32 q to the 9 r to the 4 divided by 4 q cubed multiplied by r. Well, 32 divided by 4, that's 8. And then we have q to the 9 divided by q cubed. Well, that's q to the 9 subtract 3. When we have the same base and we divide, we subtract the powers. And then we have r to the 4 subtract 1. Remember, r is the same as r to the power of 1. And now if we simplify this, we have 8 multiplied by q to the 6 multiplied by r cubed. We have 8 q to the 6 r cubed. Question number 2 for part A, we have to find the lowest common multiple of 40 and 56. Well, what we can do is find the prime factors of 40 and 56. If we consider the 40, we can split this up as 2 times by 20. 2 is a prime number, 20 isn't, so the 20 we can further split up as 2 multiplied by 10. And the 10 we can further split up as 2 multiplied by 5. Similarly, with the 56, we can split this up as 2 multiplied by 28. The 28 we can split up as 2 times by 14. And the 14 we can split up as 2 times by 7. So when we come to find the lowest common multiple, we can see the 2 is common to both. We have another 2 which is common to both. Then we have this 2 common to both. And then we multiply by the 5 and also the 7. So if we multiply these numbers together, what we end up with is 280. Then for part B, we have A, which is equal to 2 cubed multiplied by 3 multiplied by 5, and B, which is equal to 2 to the power of 2 multiplied by 3 multiplied by 5 to the power of 2. And what we have to do is find the highest common factor of A and B. Well, let's write out what A is. We have 2 times 2 times 2. Then we have 3 times by 5. And B, that's equal to 2 times 2 times 3 times 5 times 5. So when we come to find the highest common factor, what's common to both is the 2. What also is common to both is this 2. And what else is common is the 3. And what else is common is the 5. So for the highest common factor, we have 2 multiplied by 2 multiplied by 3 multiplied by 5. And if we multiply all of these together, we end up with 60. We have got the line L, which is shown on the grid, and we have to find an equation for L. Well, to find out an equation, we know that a line is of the form y equals mx plus c, where m is the gradient and c is the y-intercept. So when we come to find the gradient, we can pick 2 points, for example this and this, and then we can find the gradient by recognizing we have the change in y over the change in x. So the change in y, you can see here, we are going up by 3, and the change in x, we are going up by 1. So for the gradient, we have 3 over 1, which is 3. The y-intercept, where it crosses the y-axis, is -6. And so for the equation of the straight line, we would have y equals 3x subtract 6. Question number 4. Rhea buys a van for £8,500 plus VAT at 20%. Rhea pays a deposit for the van. She then pays the rest of the cost in 12 equal payments of £531.25 each month. We have to find the ratio of the deposit Rhea pays to the total of the 12 equal payments. Give your answer in its simplest form. Well, if she pays £531.25 each month, that means in year 1, we have 531.25 multiplied by 12. We've got 12 months. And if I work out what this is, it turns out we have 6,375. So what does this represent? Well, it represents a total of 12 equal payments. And now what we can do is find the cost of the van. So, for the cost of the van, we can first of all find out the VAT charge. And that's equal to 20% of 8,500, because that's how much the van costs. So the VAT charge will be £1,700. And so for the total charge, we have 8,500 plus 1,700, and it turns out we have 10,200. And what we can now do is find out how much deposit she pays. So for the deposits, we've got the total cost, 10,200, subtract the 12 equal payments, 6,375, and it turns out we get 3,825. And so therefore, the ratio of the deposits to the total, we have 3,825 to 6,375. Now, if we divide both sides by 25 to begin with, we end up with 153 to 255. And then if I divide by 51 on both sides, we end up with a ratio of 3 to 5. So we have 3 to 5 as our ratio. Question number 5. For part A, we have to complete the table of values for y equals x squared minus x minus 6. Well, if we go to our calculator, and if we go to the table sub-menu, key in x squared, subtract x, subtract 6, we are starting at -3, we are finishing at 3, and so when x equals -3, y equals 6, and when x is -2, y is 0. At -1, we have -4. At 0, we have -6. At 1, we have -6. And at 2, we have -4. And at 3, we have 0. And then, for part B, on the grid, we have to draw the graph of y equals x squared minus x minus 6 between -3 and 3. Well, here we've got our graph between -3 and 3. And then for part C, we have to use our graph to find estimates of the solutions to the equation x squared minus x minus 6 equals -2. Well, let's first of all draw the line y equals -2. That's shown here. And what we are doing is finding out where the graphs intersect. So the graphs intersect here and also here. We have x equals -1.6 and 2.5. So we have x equals minus 1.6, x equals 2.5. Question number 6. A force of 70 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons. The area is increased by 10 centimeters squared, and Helen says the pressure decreases by less than 20%. Is Helen correct? You must show how you get your answer. We are given that pressure is equal to force divided by area. Well, what we can do is find out what the pressure is before the increase and then after the increase. Before the increase, the pressure is equal to the force, which is 70 newtons, divided by the area, which is 20. So the pressure is 3.5 newtons per centimeter squared. After the increase, well, the force is increased by 10 newtons and the area is increased by 10 centimeters squared. So for the pressure, that's equal to 70 plus 10, which is 80, and then the area will be 20 plus 10, which is 30. And if we work out what 8 over 3 is as a decimal, we get 2.66, etc. And so therefore, for the percentage increase, we have the difference in the pressures, 3.5 subtract 2.66, etc., divided by the original pressure, 3.5, and then we multiply by 100. And so if we work this out, it turns out we get 23.80, etc. %. And this is indeed greater than the 20% which was mentioned earlier, and therefore Helen is incorrect. Question number 7. We have to enlarge shape A by scale factor 1/3 with the centre at 0, 1. Well, here to here we go 3 across and then 9 up. Here to here we go 3 across and then 3 up. Here to here we go 6 across and then 6 up. And then here to here we go 6 across and then 9 up. So, for our new shape, that means if I think about how I go from here to here, I go 3 across and 3 up, so 1/3 of that will be 1 across and 1 up. From here to here, I go 3 across and then 9 up, so 1/3 of that I need to go 1 across and then I need to go 2 up. And then we go here across by 1, because if this length is 3, 1/3 of that is just 1. And then we join these up and then join the shape up like so. Here is our enlarged shape. Question number 8. 60 people were asked if they prefer to go on holiday in Britain or in Spain or in Italy. 38 of the people were male. 11 of the 32 people who said Britain were female. 8 males said Italy. 12 people said Spain. One of the females is chosen at random. What is the probability that this female said Spain? Well, to do this, we need to recognize we've got two categories: gender, male or female, and country, Britain, Spain, or Italy. And so if we were to create our two-way table, here we have the categories, and notice we've got the totals shown here. Now, we know already that 60 people were asked altogether. So 60 goes here. We also know that 38 of the people were male. So in total we have 38 males. We know as well that 11 of the 32 people who said Britain were female, so that tells us that there's 32 people who said Britain, and of those 32, 11 of them were female. We also know 8 males said Italy, so we have 8 males for Italy, and we know that 12 people said Spain, so in total we have 12 for Spain. Now we need to find the probability that this female said Spain. So what we can do is find out the missing boxes. 60 take away 38 is 22, so we have 22 females in total. Then we have 60 take away 32 take away 12, that's 16, so we have 16 who said Italy. And then 16 take away 8 is 8, so we have 8 females who said Italy. 22 take away 8 take away 11, that's 3, so we have 3 who said Spain. 12 take away 3 is 9, so we've got 9 males who said Spain. 32 take away 11, that's 21, so 21 males said Britain. Now what we are looking for in this question is the probability that they said Spain given that they are female. So how many are female? Well, that's 22 of them. So we have 22 who are female, and of them, how many said Spain? Well, that will be 3 of them. So we have 3 who said Spain. Question number 9. Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%, and at the end of the first year, the value of Jean's investment is £12,336. In the second year, the rate of interest is X over 2%. We have to find what is the value of Jean's investment at the end of the 2 years. Well, in year 1, we invest £12,000, and then we multiply this by 1 plus X over 100. We are investing for 1 year, and at the end of it, what we get is 12,336. Now, if I do 12,336 divided by 12,000, I get 1.028. So 1 plus X over 100 is equal to 1.028. So X over 100 is equal to 0.028, and if I multiply by 100, that would mean X is equal to 2.8. So that is what the rate of interest is in the first year. Now if I take a look at the second year, what's invested in the second year would be how much we have at the end of the first year, 12,336. And then we multiply this by 1 plus 1.4 divided by 100. Well, the reason we have 1.4 is because we have the 2.8. The rate of interest in the second year is x over 2. And then we raise this to the power of 1. And it turns out what we end up with is £12,508.70. Remember, we gave our value to 2 decimal places. Question number 10. The vector A and the vector B are shown on the grid, and for part A, we have to, on the grid, draw and label the vector minus 2A. Well, if A, we are going 1 to the right and 2 up, the opposite of that would be to go 2 to the left and then 4 down. So here, we have the vector negative 2A. And then for part B, we have to work out A plus 2B as a column vector. Well, A plus 2B as a column vector, we've got the vector A, which is 1 across and 2 up. And then we add on to this 2 times by B, and we know what B is, that's 1 across 3 down. So that's 1, negative 3. And we need to work out what this is. So we have 1, 2 plus 2, negative 6. So 1 plus 2 is 3. 2 plus negative 6 is negative 4. So we have 3, negative 4. Question number 11. F and g are functions such that f of x is 2 over x squared and g of x is 4x cubed. We have to find for part A f of minus 5. Well, f of minus 5, we have to replace the x with minus 5. So we have 2 over minus 5 squared. And it turns out we have 2 over 25. And then for part B, we have to find f of g of 1. First of all, we can find out what g of 1 is. G of 1, we replace the x with 1. So that's 4 times by 1 cubed, which is 4. So when we come to find out what f of g of 1 is, that is the same as replacing, well, that is the same as working out f of 4. So we replace the x with 4. So we have 4 multiplied by 4 cubed, rather f of 4, that's equal to 2 over, and then here we have 2 over 4 squared, which is equal to 1/8. So we end up with 1/8. Question number 12. The graphs of y against x represent 4 different types of proportionality. To match each type of proportionality in the table to the correct graph? Well, y being proportional to x, that's a straight line through the origin. In other words, what we could really plot here is y equals x, and that will be graph B. Now, where we have y being proportional to x squared, well, that's pretty much the same as plotting y equals x squared. And if I take a look at the graphs, that will correspond to graph D for positive x values. Y being proportional to the square root of x, well, we could think about plotting y equals the square root of x, which will be a, and then y equals 1 over x. Well, we can think about plotting y equals 1 over x, which is c for positive x. Question number 13. A, B, C and D are points on the circumference of a circle with centre O, and FDE is a tangent to the circle. We have to show that y minus x equals 90, giving a reason for each stage of your working. Well, what we can see over here is we've got a tangent and we've got OD, which is a radius. And so therefore, because we know that the tangent and radius meet at 90 degrees, that means the angle here is 90 degrees. So the angle ODF is equal to 90 degrees because the tangent is perpendicular to the radius. And because this angle here is x, that means here this angle will be 90, which is this 90 here, subtract x. So therefore, the angle BDF is equal to 90 minus x. Now, if this angle here is y, that means the angle here will be 180 minus y, because vertically opposite angles in a cyclic quadrilateral sum to 180. So we have BCY equaling 180 minus y. So BCY is 180 minus y because opposite angles in a cyclic quadrilateral sum to 180. And what we can see then is the angle BCD is equal to the angle BDF. So this angle here is equal to this angle here, and that's because of the alternate segment theorem. So let's write that down. We've got the angle BCD. Here we've got BCD. This is equal to BDF, and the reason for that is because of the alternate segment theorem. So in other words, BCD, that's 180 minus y, and that's equal to 90 minus x. And if we rearrange, we can therefore conclude y minus x is equal to 90. Now for the Next part of the question, Dylan was asked to give some possible values for x and y. He said y could be 200 and x could be 110 because 200 take away 110 is 90. Is Dylan correct? Well, if I think about this 180 minus y must be less than 180, otherwise we'd have a negative angle for BCD. So y must be less than 180, and that's because otherwise the angle BCD will be negative. And so therefore, y cannot equal 200, and therefore Dylan is incorrect. Question number 14. The distance time graph shows information about part of a car journey. We've got the distance travelled in meters and the time in seconds, and we have to use the graph to estimate the speed of the car at time 5 seconds. Well, at 5 seconds, what we can do is draw a tangent to the curve at 5 seconds. So if we do that, we have something looking like this. Now, what we need to do is find the gradient of this line, which will tell us the speed of the car at 5 seconds. So the coordinates here, we've got 3, 0, and the coordinates here, we've got 8, and then here we've got something just above 70. So we've got 4, 8, 12 plus 60, which is 72. So now we need to find the gradient with those points. So the gradient, we've got the change in y, 72 take away 0, divided by, so we have divided by the change in x, 8 take away 3, so we have 72 over 5, which is 14.4. So we have 14.4 meters per second. Question number 15. A darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on Saturday, the probability that they will win on Sunday is 0.67. If they do not win on Saturday, the probability that they will win on Sunday is 0.35. For part A, we have to complete the tree diagram. Well, if the probability of winning on a Saturday is 0.45, one subtract 0.45 is 0.55. So that's the probability of not winning on a Saturday. Now we know that if we win on a Saturday, the probability of winning on a Sunday is 0.67. And so the probability of not winning on a Sunday is 1. Subtract 0.67, which is 0.33. Now, the probability that, well, we know that if they do not win on Saturday, the probability that they will win on Sunday is 0.35. So the probability that they do not win on Sunday, then, if they do not win on Saturday, 1 subtract 0.35, that's 0.65. So here is the complete tree diagram. And then for part B, we have to find the probability that the team will win exactly one of the two matches. So the probability that they win exactly once that's the probability of winning on a Saturday, followed by the probability of winning on a Sunday, or the probability of not winning on a Sunday, or the plus the probability of not winning on a Saturday, followed by the probability of winning on a Sunday. So let's work this out. We've got 0.45, that's the probability of winning on a Saturday, and the probability of not winning on a Sunday after that will be 0.33. And then the probability of not winning on a Saturday, that's 0.55. And then the probability of winning on a Sunday, that will be 0.35. So if I work all of this out, we end up with 0.341. Question number 6. For part A on the grid, we have to draw the graph of x squared plus y squared equals 12.25. Well, here we can find out what the radius is. R squared will equal 12.25, which means r is equal to the square root of 12.25, which is 3.5. So what we need to do is draw a circle with the centre at the origin with radius 3.5. So let's stretch this appropriately until we get 3.5. So 3.5 is here, and then finishing this off like so, we have our circle. So I've got the graph x squared plus y squared equals 12.25. And then for part B, hence find estimates for the solutions of these simultaneous equations, x squared plus y squared equals 12.25 and 2x plus y equals 1. Well, from here I can write this in the form y equals mx plus c to find an equation of the straight line. That will be y equals minus 2x plus 1, gradient of negative 2, y-intercept of 1. We need a straight line that satisfies those. So it crosses at minus 1, gradient of negative 2, so for every 2 we go down, we go 1 across. So here is the required it crosses through 1. So gradient of negative 2, so for every 1 we go across, we go here. We've got the line y equals negative 2x plus 1. So now we need to find out the intersection points. Well, we've got an intersection point here and also here, so we've got minus 1.1 and 3.2. So there's one intersection point, and for the other one, we've got 1.9 and minus 2.8. So we've got solutions. X equals negative 1.1 and the corresponding y to that was 3.2. And we also have x equals 1.9 and the corresponding y was negative 2.8. Question number 17. The histogram shows information about the times taken by some students to finish a puzzle. That's what we see here. And for part A, we have to complete the frequency table for this information. Well, if we were to complete the frequency table, well, what we need is information about the class width, and we also need information about the frequency density. Class width here is 5, here it's 10, here it's 10, here it's 5, and here it's 20. Now for the frequency densities, well, we can read those off. We've got 0.8, then here we've got 0.4, then here we've got 0.6, and then here we've got 1.0, and then finally we've got 0.2. And what we can do to find the frequencies is multiply the frequency density by the class width. 0.8 times 5 is 4, 0.4 times 10 is 4, 0.6 times 10 is 6, 1 times 5 is 5, 0.2 times 20 is 4. So here is the completed frequency table. And then for part B, we have to find an estimate for the lower quartile of the times taken to finish the puzzle. Well, we need another column, the cumulative frequency column. We start off with 4, 4 plus 4 is 8, plus 6 is 14, plus 5 that's 19, plus 4 that's 23. So now what we can do is find out the position of the lower quartile. So for the position of the lower quartile, we've got 23 plus 1 divided by 4. We want the sixth value. And the sixth value, what interval would that lie in? Well, that will lie in the interval 5 to 15. So we need to be focusing on the 5 to 15. So if we create a diagram to help us do this question, we want to find the lower quartile, we'll call it Q1. So we can see that there are 4 pieces of, well, let's add on our intervals. We've got 5 to 15. Now, we can see from the table there are 4 pieces of data which are 5 or less. So 4 goes here. And for 15, we can see that there are 8 pieces of data 15 or less. And we know that the lower quartile, that's the 6th piece of data we want. So we can use linear interpolation to help us find out what Q1 is. If we think about the gradient of this line being the same throughout, then what we can say is Q1 subtract 5 divided by 6 take away 4, that's equal to 15 take away 5, divided by 8 take away 4. So now we can find out what Q1 is. Q1 then is equal to 15 take 5 divided by 8 take 4 multiplied by 6 subtract 4 plus the 5. And if I work this out, I get 20. So therefore, the lower quartile is 20 minutes. Question number 18. A, B, C, D, E, F, G, H is a cuboid. AB is equal to 7.3 centimeters. CH is equal to 8.1 centimeters, and the angle BCA is 48 degrees. We have to find the size of the angle between AH and the plane ABCD. Give your answer correct to 1 decimal place. So what do we know so far? Well, we've got AB, which is 7.3 centimeters. So here we have 7.3. Then we've got CH, which is this length here, which is equal to 8.1 centimeters. And what we can do is, well, if I think about what I need to find the angle between AH, so here is AH, and the plane. So if I draw a line here to here, then I need the angle that is over here, and let's call this angle X. So how could we go about that? Well, I've got the angle BCA, which is this angle here, equaling 48 degrees. So let's find out what AC is. So if I draw that triangle, I've got the triangle shown here, which is the triangle ABC. And what I know is AB is 7.3. BC I don't know yet. I've got 48 degrees here. I've got a right-angled triangle. So from this I can find out what AC is. So if I find out what AC is, well, I've got the sine of 48, which equals 7.3 divided by AC, which is the hypotenuse. And so therefore, AC, that's equal to 7.3 divided by the sine of 48, which is, well, if I write this down, I've got AC, which is equal to 9.82, etc. So this length here is 9.82, etc. Now if I draw the triangle ACH, I've got ACH. I'm finding this angle. I've got the side AC, which is 9.82, etc. And then here I've got 8.1. So here is that triangle, and to find out x I need to be using tan. So I've got tan x equals 8.1, which is the opposite, divided by AC, which is 9.82, etc. And from this we can find out what x is. X will equal the inverse tangent of 8.1 over this, which is 39.5, etc. degrees. So I have 39.5 degrees given to 1 decimal place. Question number 19. Shape S is 1/4 of a solid sphere with the center at O. The volume of S is 576 pi centimeters cubed. We have to find the surface area of S to 3 significant figures showing all of our working. We know the volume of a sphere is 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared. So what we can do is find out the volume of S. So for the volume of S, that's equal to, well, I've got 1/4 of a solid sphere, and then I multiply this by 4/3 pi r cubed. I don't know what the radius is. Now if I simplify this, it turns out we get 1/3 pi r cubed for the volume of S. And I know that the volume is 576 pi. So I've got 1/3 pi r cubed equals 576 pi. The pi's cancel on both sides. So I've got r cubed, which is equal to 1728, which means r is equal to the cube root of this, which is 12. Now how do I find out the surface area? The surface area, well, I've got the semicircle here and the semicircle here, so 2 semicircles make a full circle, so that's pi r squared. So let's just write down this. We've got 2 semicircles, and that would make a full circle. And then we've got 1/4 of the outer bit, and the outer bit, that will be 4 pi r squared. So we've got 4/3 times by 4 pi r squared. So we have 2 pi r squared. And I know what r is, that's 12, so I've got 2 pi times by 12 squared, which is 288 pi. 288 pi, that's 904.77. So I have 904, well, to 3 significant figures, and I've got 905. Question number 20. Martin did this question. We have to rationalize the denominator of 14 over 2 plus root 3. Here's how he answered the question. So he multiplied both the numerator and the denominator by the conjugate of the bottom. So he multiplied top and bottom by 2 minus root 3. That's fine. And if I expand along the top, 14 times 2 is 28. 14 times minus root 3, that's correct. On the bottom I've got 2 times 2, which is 4. 2 times negative root 3 is negative 2 root 3. Root 3 times 2 is positive 2 root 3. And then here I've got root 3 times negative root 3. That's negative 3. So here is the error. So this is the error So the error is in line 2. And what he did when he expanded 2 plus root 3 times 2 minus root 3, well, I agree with the 4, I agree with the 2 plus root 3, I also agree with the negative 2 root 3, but then root 3 times negative root 3 is minus 3, and all this simplifies to 1. So what's the mistake he made? He expanded wrong. Sean did this question. We have to rationalize the denominator of 5 over root 12. Here's how she answered the question. Multiply the top and bottom by root 12. So I've got 5 multiplied by 3 root 2. Well, 3 root 2 is incorrect because, well, here's the error. Because, well, that's in line 2. The root 12 shouldn't simplify to that. So the root 12 equals root 4 times root 3, which is 2 root 3, not 3 root 2. So what's the error then? Well, the error is they've simplified the root 12 incorrectly. Question 21. Jackson is trying to find the density in grams per centimeters cubed of a block of wood. The block of wood is in the shape of a cuboid. He measures the length as 13.2 to the nearest millimeter, the width as 16.0 to the nearest millimeter, and the height as 21.7 centimeters to the nearest millimeter. And he measures the mass as 1970 grams, correct to the nearest 5 grams. By considering bounds, we have to work out the density of the wood. Give your answer to a suitable degree of accuracy, showing all of your working and giving a reason for your final answer. Well, here is our block of wood with the dimensions added on. What we can do is find the upper bound and the lower bounds of each of the dimensions. So the upper bound of the length is 13.25 and the lower bound of the length is 13.15. The upper bound of the width is 16.05 and the lower bound of the width is 15.95, and of course we've got centimeters. The upper bound of the height, that is 21.75 centimeters, and the lower bound of the height is 21.65 centimeters. And with these we can find out the upper bound of the volume. That's equal to the upper bound of the length times the upper bound of the width times by the upper bound of the height. So I have here 13.25 times 16.05 times 21.75, and if we work this out, we have 4,625.409375 centimeters cubed. And for the lower bound of the height, I've got 13. Well, let's just write this out in full. I've got the lower bound of the length times the lower bound of the width times by the lower bound of the height. So I've got 13.15 times 15.95 times by 21.65. So if we work out what this is, well, let's just store this into A. Got 13.15 times 15.95 times 21.65. It turns out we get 4,540.925.125 centimeters cubed. Now let's just store this into B just in case we need it later on. Now we were also given the mass to the nearest 5 grams, so the upper bound of the mass is 1972.5 grams and the lower bound of the mass is 1967.5 grams. And with this, what we can now do is find the upper bound and the lower bound of the density. The upper bound of the density is equal to the upper bound of the mass divided by the lower bound of the volume. So I've got the upper bound of the mass, 1972.5, divided by the lower bound of the volume, 4540.925. So let's work this out. I've got 1972.5 divided by this, and it turns out the upper bound of the density is 0.4343828.506 grams per centimeters cubed. And the lower bound of the density, we've got the lower bound of the mass divided by the upper bound of the volume. So I have 1967.5, and I'm going to be dividing this by the value here. So if we work out what this is, I've got 1967.5 over that value here, which is 0.4253677.546 grams per centimeters cubed. And so if I look at the upper bound and the lower bound, we can see that they both round to 0.43 grams per centimeter cubed. So therefore the density is equal to 0.43 grams per centimeters cubed to a suitable degree of accuracy. And the reason for this is because both the upper bound and the lower bound of the density round to this to a suitable degree of accuracy.